everyone. This is the 10th lecture of our series, data science series, and our topic of today is dimension reduction. So, today we are diving into this fascinating world of dimensional reduction. It is a critical technique in data science for simplifying data sets and making machine learning models efficient. Now, what we'll explore firstly, what is dimension reduction and identifying multicollinearity in data set, and then PCA, that is principal component analysis, and then we'll implement these concepts in Python step by step. So, firstly, understand what is dimension reduction. So, in data sets, we often deal with large number of variables or features. While having more data is great, too many features can lead to issues like complexity, overfitting, multicollinearity. Complexity as the model becomes harder to interpret. Overfitting means the model may perform well on the training data but poorly on unseen data. And then multicollinearity, that is predictors are highly correlated, making it hard to determine the individual effects. And this is our multicollinearity. It occurs when two or more predictors in a model are highly correlated. That this can cause problems in regression model, and it is hard to determine which predictor is influenced by a target variable. This is our word autonomy for multicollinearity, where multi stands for referring to the multiple independent variables within multiple regression. Call means modification of the prefix co, meaning that together joined or referencing the linear movement in tandem, that is correlation, and linear, that is occurring with a linear equation, and it means suffix meeting the meaning of the quality state. Now, for example, consider you have x1 and x2, where x2 is almost scaled in the one version of x1, and then they'll compare for the importance in the model, leading to the unstable coefficient. Now, how to detect multicollinearity? So we use a metric called variance inflation matrix, that is VIF, to detect multicollinearity. We'll understand about it later. Now, next on we have principal component analysis. That now it is a uh, statistical technique for that transforms data set into orthogonal components like principal components. So PCA works by transforming the original features into a new set of orthogonal components known as principal component, and where each principal component is a combination of original features. It explains the portion of the variance in the data and is uncorrelated with the other components. This is our 3D dataset being transformed into 2D dataset using PCA. Now, steps to perform PCA. So, we standardize the data, then compute principal components, that is calculate the components and capture the maximum variance, and third, choose the number of components, that is we select the components based on how much variance they explain. Now, in this code, we have imported libraries, and then we are creating a synthetic data set where we are seeding it, and where x1, x2, x3, x4 are the some features, and then we need to correlate them with, for example, here x2 is correlated with x1, and x5 is some correlation between x3 and x4, and then we are combining it into a data frame. Let's try to run it again. Yeah. So here we have our combined data frame. Now, next on, we'll calculate the variance inflation factor, that was VIF. This is our output. Now, to keep things to keep things in mind while using VIF, that is, if VIS is greater than 5, it indicates moderate multicollinearity, and if VIF is less is greater than 10, it's of multicollinearity and the need for corrective action. So here we have seen that most of our features are greater than 10, that is, it's severe multicollinearity. Now, standardizing the data set and then applying PCA and explained variance here, you can see, and then we are plotting. Plotting means visualizing our model. So this is how variation is there between all the between all the features, and then we have taken out their PCA also. So this was our PCA, and we have seen the output, and the explain variance ratio tells us how much the variance of each component captures, and the cumulative experience variance plot. This explains how many components to keep, and this was our data set. Now we have also some difference between multicollinearity and PCA. So PCA, the problems multicollinearity solve is about the correlation between predictors, and PCA solves about the high dimensionally in data sets. Now how they both solve it? So multicollinearity identifies and remove the correlated features, whereas PCA transform features into uncorrelated components. And multicollinearity use VIF, that is variance influence factor, and PCA use principal component analysis. And then both difference, the goal for multicollinearity is to simplify interpretation of regression coefficients, and PCA is to retain maximum variance with fewer variation. So that's a wrap for this video. We have explored how to detect multicollinearity using VIF and PCA to simplify data sets and improve model performance. That's it for this video. Thank you.